SpaceX embarks on pivotal ninth Starship test flight. Beyond its own ambitions, SpaceX's progress with Starship is reshaping the landscape of the global space industry. Starship's fully reusable architecture has the potential to drastically lower launch costs, enabling a new era of commercial spaceflight, satellite deployment, and deep space missions. Experts note that a reliable and cost-effective heavy-lift vehicle could unlock a range of possibilities, from deploying large space telescopes and planetary probes to supporting lunar infrastructure and Mars-bound cargo missions. It could also accelerate the development of space-based industries like in-orbit manufacturing and tourism. Competitors and international space agencies are also taking notice, while countries such as China, India, and members of the European Space Agency work on their own heavy-lift capabilities. The rapid pace of SpaceX's Starship testing sets a high bar. Community and environmental considerations. As Starship testing continues, SpaceX has also faced scrutiny from environmental groups and local residents near the Starbase launch site. Concerns have been raised about the ecological impact of frequent launches and debris from failed tests. SpaceX has worked with the FAA and other agencies to address these issues, including efforts to monitor and mitigate impacts on the surrounding wildlife and coastal environment. At the same time, enthusiasm remains high among space enthusiasts and local supporters who see Starbase as the birthplace of a new space age. Crowds gathered once again to witness the ninth flight, with cheers erupting as the rocket soared into the sky. Conclusion. The ninth integrated test flight of Starship marks a significant step forward in SpaceX's ambitious roadmap. While full reusability and orbital missions still lie ahead, this mission demonstrated meaningful progress in system reliability, control, and recovery, a testament to SpaceX's aggressive development strategy. As the company reviews the data and prepares for its next flight, one thing is clear: the era of super heavy, fully reusable spaceflight is no longer just a concept, it's rapidly becoming reality. During the flight, the Super Heavy booster executed a planned boostback burn and descent trajectory, while SpaceX has previously conducted successful ocean splashdowns and landings. This mission aimed to further test the booster's ability to control its descent using grid fins and engine reignition. Meanwhile, the Starship upper stage continued on a suborbital trajectory, reaching high altitude before re-entering Earth's atmosphere. The spacecraft faced intense heat and pressure during re-entry, putting its newly upgraded heat shield and flight control systems to the test. According to preliminary data, the vehicle performed as expected, marking significant progress in SpaceX's ability to recover and reuse Starship. Looking ahead, the flight is another milestone in SpaceX's rapid development cadence. As part of its iterative testing approach, the company has embraced a fail-fast, learn-faster philosophy, rapidly identifying issues and implementing improvements between flights. NASA and other stakeholders are closely monitoring Starship's progress. Under a $2.9 billion contract with NASA, SpaceX is tasked with developing a version of Starship that will serve as the lunar lander for Artemis 3, the first crewed moon landing since Apollo. With each flight, SpaceX inches closer to achieving its broader goals of interplanetary transport. CEO Elon Musk has repeatedly stated his vision of establishing a self-sustaining city on Mars, and Starship is central to that vision. If data from the ninth flight confirms the success of key systems, SpaceX could move closer to conducting its first orbital refueling test and, eventually, the first crewed Starship missions. SpaceX launched its ninth integrated flight test of the Starship vehicle on Tuesday, marking a critical step in the company's efforts to develop the world's most powerful and fully reusable rocket system. The test flight, which took place from SpaceX's Starbase facility in Boca Chica, Texas, is part of a broader plan to eventually carry cargo and crew to the Moon, Mars, and beyond. Lifting off atop the Super Heavy booster, Starship soared skyward in a dramatic display of raw power and precision. The mission aims to build on the progress made during previous flights, focusing on refining re-entry procedures, stage separation, and splashdown recovery capabilities. The stakes are high for this test, as SpaceX seeks to validate crucial updates to both hardware and software. Engineers made several adjustments following the eighth test flight, including improvements to heat shield tiles, control surfaces, and the vehicle's Raptor engines. Each flight is a learning opportunity, SpaceX stated on X, formerly Twitter, ahead of the launch. The data from today's test will help us continue to advance Starship's development as we prepare for future missions. Early indications suggest the flight achieved several of its primary objectives. though full analysis will follow in the coming days as SpaceX reviews telemetry data and on-the-ground observations. Starship, when operational, is expected to become the backbone of NASA's Artemis program for lunar missions and serve as a cornerstone of Elon Musk's long-term vision to establish a human presence on Mars. As the aerospace world watches closely, this 9th flight marks a pivotal moment in SpaceX's ambitious journey to revolutionize space travel. One of the central goals of this 9th test flight was to demonstrate improved reusability, a key factor in reducing the cost of space access. Both the Super Heavy booster and the Starship upper stage are designed to be fully reusable, with the potential to land and be launched again within hours. Implications for the space industry. Here's a natural extension of the article, focusing on what comes next for Starship and SpaceX, including anticipated developments, upcoming missions, and broader implications. Extended features, choose one or more. Exclusive interview simulation, a fictional but realistic QA with Elon Musk or a SpaceX engineer, adding a human voice to the story. Technical breakdown, a sidebar-style explainer of Starship components, e.g., Raptor engines, heat shield, Super Heavy booster, ideal for readers who want more science and engineering. Timeline of Starship milestones, a chronological graphic or text feature tracing every Starship test flight and major update. Impact analysis, a deeper dive into how Starship could disrupt commercial space, national defense, climate monitoring, or even international geopolitics. Public reaction, cultural impact, highlights of fan engagement, viral moments, memes, and how Starship has captured public imagination. Future missions preview, a forward-looking piece on planned missions, Artemis 3, Dear Moon, Mars cargo drops, etc., with speculative insights based on current progress. Would you like me to develop one of these? Or if you're preparing a publication, I can format and structure the entire multi-part article into a single export-ready document. Starship and the future of space exploration. As the dust settles from the 9th test flight, it's clear that Starship is not just a rocket, it's a symbol of what's possible when technological ambition meets relentless execution. With each launch, SpaceX moves closer to making multiplanetary life a tangible goal rather than a distant dream. The implications of a fully operational Starship are vast. It could enable mass deployment of satellites for global communications, serve as a logistics platform for lunar bases, and eventually transport the first humans to Mars. The spacecraft's immense payload capacity and cost efficiency could also democratize access to space, opening the door for scientific missions, educational programs, and entrepreneurial ventures once thought unfeasible. Beyond its hardware, Starship represents a shift in how the world approaches spaceflight, agile, private sector-led innovation that challenges traditional timelines and paradigms. While risks remain and technical hurdles still lie ahead, the pace at which SpaceX is advancing puts it at the forefront of a new era in human exploration. From Earth to the stars. If the past decade was about reaching orbit reliably and affordably, the next may be defined by where we go from there. Starship is the vessel SpaceX believes will take us, not just back to the moon, but far beyond, toward building permanent outposts, exploring other worlds, and expanding the boundaries of human civilization. As SpaceX prepares for its 10th test flight and beyond, the aerospace community, governments, and the public are watching a story unfold that could redefine our species' relationship with the cosmos. Starship is still in its testing phase, but its trajectory is clear, upward and outward. What's next for Starship? Following the success of the 9th test flight, all eyes are now on what comes next for SpaceX's Starship program. According to company officials, the next major milestones will include first full recovery attempts. While SpaceX has demonstrated controlled descents and splashdowns, future flights may attempt to land both stages either on platforms at sea or at the launch site, paving the way for full reusability. Orbital refueling tests, a key requirement for deep space missions, especially to the Moon and Mars, is the ability to refuel Starship in Earth orbit. SpaceX is preparing for test flights that will involve docking 2 Starships in space and transferring cryogenic propellant, a complex maneuver that has never been done before. Crewed flights and lunar preparations. SpaceX continues working closely with NASA to tailor Starship for the Artemis 3 mission. Although the timeline is fluid, successful test flights over the coming months could set the stage for an uncrewed moon landing rehearsal before astronauts ride Starship to the lunar surface. Commercial and international missions. Beyond NASA, SpaceX has announced partnerships for private lunar missions. such as the Dear Moon project led by Japanese entrepreneur Yusaku Maezawa. The project envisions flying artists and creatives around the moon aboard Starship. Meanwhile, discussions are ongoing with other countries and commercial customers eager to leverage the vehicle's capacity for cargo and crew. The road ahead. The development of Starship is one of the most ambitious aerospace engineering challenges ever undertaken. It involves mastering technologies that touch on nearly every aspect of rocket science, from ultra-high thrust engines and thermal protection to orbital rendezvous and deep space life support. Despite early setbacks and explosions that garnered media attention, each Starship test flight has pushed the envelope further. SpaceX's rapid iterative approach, combined with a willingness to take calculated risks, has allowed the company to advance at a pace rarely seen in space exploration. If Starship achieves operational status in the near future, it will represent not only a breakthrough for SpaceX, but a paradigm shift for humanity's ability to access and utilize space. Absolutely. Here's the final section, offering a visionary wrap-up that underscores the broader significance of SpaceX's Starship program and its place in the future of space exploration. You've now got a complete, comprehensive article arc, from launch details to future vision, but if you'd like to go even further, here are a few meaningful directions we can take next. Behind the spectacle of liftoffs and fiery landings lies one of the most complex aerospace systems ever built. The Starship launch system is composed of two main stages, the Super Heavy booster and the Starship upper stage. Together, they form the tallest and most powerful rocket system in history, designed to be fully and rapidly reusable. Upcoming Starship missions, what's on the launch pad? With the 9th test flight complete and key systems validated, SpaceX is preparing for a bold set of upcoming missions that will test Starship in more dynamic and operationally relevant scenarios. These missions will move beyond suborbital flights and controlled splashdowns, toward true orbital operations and eventual crewed missions. 1. Flight 10, Full Recovery Attempt. Goal, launch, stage separation, and controlled returns of both Super Heavy and Starship, targeting land-based or platform landings rather than splashdowns. Key objectives: improve landing accuracy, test pad landing protocols, gather high-fidelity data on heat shield performance during re-entry. 2. Tanker test mission. Goal: demonstrate in-space refueling between two Starship vehicles, a critical component for deep space missions. Why it matters. Starship can't reach the Moon or Mars without refueling in Earth orbit. Success would establish a refueling network, allowing Starship to act like a space tanker truck. 3. Uncrewed lunar demonstration for Artemis program. Goal: simulate a landing on the Moon using the Human Landing System, HLS, variant of Starship. NASA Milestone. This mission will serve as a precursor to the first crewed Starship lunar landing as part of Artemis 3, expected in the late 2020s. It will test precision landing, dust mitigation, and communication systems in the lunar environment. 4. Dear Moon project. Type: crewed circumlunar flight. Passenger list: Japanese billionaire Yusaku Maezawa plus selected artists and creatives. Mission plan: a week-long journey around the Moon and back to Earth. Why it's unique. First commercial crewed mission on Starship. Focuses on cultural and artistic impact of space travel, not just scientific milestones. 5. Mars Cargo Pathfinder, future milestone. Timeline: late 2020s, tentative. Mission: deliver cargo and autonomous systems to the Martian surface ahead of a future crewed mission. Objectives: test Starship's thermal protection during interplanetary re-entry. Begin surface infrastructure for human arrival. Demonstrate in-situ resource utilization, ISRU, equipment, like methane production from CO2. Starship's roadmap, a multi-stage journey. Each of these upcoming flights serves a specific purpose in Starship's evolution. Orbital mastery, flights 10 to 12. Fuel logistics in space, tanker tests. Deep space navigation, circumlunar and lunar missions. Planetary readiness, cargo Mars flights. This roadmap is both aggressive and flexible, adapting to results from each prior test. SpaceX's iterative model allows them to learn fast and deploy improvements with unprecedented speed. Super Heavy booster. Height: 71 meters, 233 feet. Engines: up to 33 Raptor engines. Thrust: over 16 million pounds, 72 mN, at liftoff. Roll: provides the raw power needed to escape Earth's gravity. It lifts Starship through the lower atmosphere before separating and returning for a soft landing. Key features: grid fins for controlled descent. Boost back and landing burns to guide it to either ocean splashdown or pad landing. Stainless steel structure offering strength and heat resistance. Starship upper stage. Height, 50 meters, 164 feet. Engines, 6 Raptor engines, 3 sea level, 3 vacuum optimized. Payload capacity, 100 metric tons to low Earth orbit. Role, carries crew, cargo, or satellites into space, and is designed to land vertically on Earth, the Moon, or Mars. Key features. Thermal protection system, TPS hexagonal ceramic tiles shield the vehicle from the intense heat of re-entry. Large payload bay, accommodates satellites, cargo modules, or crewed habitats. Flaps and aero surfaces, provide aerodynamic control during descent through atmospheres. Refueling capability, designed to dock with another Starship in orbit and transfer cryogenic fuel. Raptor engines, type, full-flow staged combustion. Fuel, methane and liquid oxygen, CH4/LOX. Thrust, sea level 230 metric tons per engine. Efficiency, high performance, designed for deep throttling and multiple restarts. Methane was chosen not only for performance, but because it can potentially be produced on Mars using local resources, an essential feature for interplanetary missions. Innovation highlights. Rapid reusability. Starship aims to be reused within hours, akin to an aircraft turnaround, drastically lowering costs. Stainless steel body. Unlike most rockets made of aluminum or carbon composites, Starship uses stainless steel for its high durability, especially under thermal stress. Heat shield tiles, designed to withstand multiple re-entries. These lightweight ceramic tiles are mounted individually for easy replacement. The bigger picture. Starship isn't just a rocket, it's an entire launch architecture. SpaceX envisions using it for Moon and Mars colonization, satellite constellation deployment, point-to-point Earth travel, space-based infrastructure like fuel depots and orbital stations. Every flight test, even partial successes, brings SpaceX closer to maturing this ecosystem. Excellent, let's keep building. Following the technical breakdown, here's the next logical section, upcoming mission profiles, giving readers a look ahead at what SpaceX is planning for Starship in the near future and how these missions fit into broader goals.